So hey guys, this is Sahil here, and I'll be showing you a quick working demo of our uncertainty system, KAIROS. So let me just brief you about what KAIROS is basically. So KAIROS is technically uh, so I was talking about KAIROS. So this is KAIROS. It's an algorithm that we have designed and programmed. So basically what it does, it first takes a user query. User asks a simple question to the system. For example, a famous question that we discovered while making this, which is how many moons does Saturn have? Then it gets multiple answer samples, asks the same question repeatedly, n times maybe, with the same temperature to check for any variation or uncertainty. Then it extracts the claims, breaks the answer into small factual claims, and each claim is scored separately. And for scoring, we have our equation, that is this u is equivalent to he norm into g norm into inconsistency. So this is our master equation that computes the uncertainty pressure. Firstly, we have the epistemic entropy, the structural gradient, the inconsistency, and then after calculating the uncertainty pressure, it assigns zone to it, risk levels, based on u score, that is solid, gradient, or fault line. If the claim is solid, you can trust the claim. If it's gradient, you need to check before using. If it's fault line, you have to verify it first. It may be wrong or it may be not wrong, but it has to be verified. And the output is KAIROS field. We return it using all the scores and stuff. So the key idea here is that I have just written it here also. It's not about if the model is wrong or not, but it just shows you how much uncertainty does each claim have when you ask something to an AI. And nobody does that. Nobody calculates uncertainty per claim. It's the first thing, it's first of its kind algorithm. So now enough of this theory bullshit. I'll just show you the live working demo. This is the whole code base. I'll just so we have two interfaces for it. One is a CLI interface, and honestly nobody wants that because it does not look cool. And then we have the GUI, which does look cool. So let me just open that, and here we have the UI, which is a neo brutalist UI. Very cool, very sexy. So firstly, on the left hand side, we have all of the previous claims, and tiny little credit to ourselves. Sahil Maharaj, that's me, and Abdul Kafil, he's my buddy. We did this algorithm together. Here you can select language, and here you have a dark mode. I'll just stick to the light mode for now, and then we have the NVIDIA NIM API connected. So basically we needed an AI model to ask the questions to. So we used NIM API key by NVIDIA because it was free of cost, totally free, and it's really cool. You can make some really cool projects with it. I recommend it if you want some free AI model. And exactly, the model is, I guess, Llama 3.2. So here we have the field, the main field. Here I ask the question. Here you can put the number of samples, how many number of samples you want. I'll just put it to 6 for now. And here you have the temperature. So I'll be asking it a very historical question, that is, who is responsible for the revolt of 1857 in India. I'll just run the KAIROS pipeline, and here you can see it is executing all the logs, and here it's sampling it, so it's going to take some time. I'll just pause it and then show you the result directly. So bingo, we have the results here, and we have some real cool results. So let me first show you this. So the algorithm returned a total of 13 claims, out of which it classified 4 to be solid claims that you can trust totally, 7 gradient claims, and 2 fault line claims. So you need to check these 2 claims. In gradient, it's maybe or maybe not, that kind of shit. And here it's the primary model response. And then we have the detailed claim analysis. Here we have all the claims that have been classified, and here you can see the uncertainty pressure of each, the epistemic entropy, the structural gradient, the inconsistency, and you can see them zone wise, fault line. So you can check these claims for themselves, because and here we have the mathematical foundation in theory. I just showed this equation. This is the master equation. It just does all the math and gives us the uncertainty pressure. And now if we go up, and we have this really cool field map. It just 2D map of all the claims against uncertainty pressure of structural gradient, of course. So here we have the solid claims, the 4 solid claims. It's very beautiful. And the gradient claims, and finally the solid claims. The reason why I asked a historical question is because the AI model can get these facts wrong. Otherwise, asking it a simple mathematical question or stuff, that obviously won't be uncertain, but this is something it can get wrong sometimes. So you have also this option to export as a report, and here you have the dynamic zone thresholds. So this was how KAIROS works, and I just showed you a demo of it, a working quick demo of it. So there's a lot of stuff you can do with this. You can use this and build upon it, or this is a very cool algorithm. And let me tell you, this is first of its kind. Nobody has done this before. Nobody has calculated the uncertainty per claim and then showed it like this. Nobody has done it before, and Kafil and me are the first ones to do it. And KAIROS is the first algorithm of its kind. And speaking as of now, we have written the code for now. This is the first version of it, as you would say, the first version. We'll be adding more stuff to it. We'll be decreasing the latency, making it quickly fast, which is going to be expensive, but we'll have to figure out a way. We'll have to make it affordable and really quick, so that it does not take this amount of time, and we'll add some more features to it. As of now, we have finished the code, but we are working on a research paper for this KAIROS, because it took a lot of research to get this equation, because earlier we had another equation, a lot of equations, and all of those used to give us wrong results, and we ran tons of experiments, and this equation is the closest we came to a perfect one. And KAIROS, we are going to soon publish that paper too, and if any good journal accepts us, that is, otherwise you won't be. I hope any good journal accepts us and publishes our paper. By the way, if you want the code of this and run this locally on your system, I would be glad to share that. Just contact me. And this is it. This is our KAIROS. Really cool stuff, really cool algorithm. Thank you.